So the type of work we're doing is important for these types of continuum medical robots, mainly because these robots are great for these types of environments inside the body, these highly constrained environments, and these robots are able to conform to these types of cavities, etc., and they're inherently safer, much more compliant, but it becomes a lot harder to actually track their location and their shape inside the body. And so if we are able to do that more easily, then that would be a great benefit to both the patients and the surgeons.
We did work with a growing robot, which is a robot made of a very thin ripstop nylon that we invert inside itself, almost like a sock, and then pressurize with a fluid, which causes the robot to grow. We think this robot has a lot of potential for use in medical applications because it's inflatable, it's soft, and it transmits very little force to its surroundings. So it can be used in delicate places like arterial passageways in the brain. So we looked at using magnets instead to track the tip of the robot so that you could know where the robot is without having to constantly image under fluoroscopy. So now to track the tip of the robot, we just have to be able to track the magnet. We have an idea of where, or of how strong the magnetic field should be around the magnet. And so if we have a bunch of sensors around the magnet that measure the magnetic field strength, we can determine where the magnet is. We trained a neural network to learn the difference between what our sensors were reading and what our model said the sensors should be reading. And then together, using that physics-based model and our neural network, we improved our localization accuracy in tracking the tip of these growing robots. Yeah, altogether, our 4 sensors, our magnet, and our microcontroller, it's about a $100 system.
I guess ideally, we are hoping that we can help develop these types of growing robot technology, push it forward so that we can actually try to test it in a clinical setting, move it forward and actually be translated into clinical use.